students. Welcome to the lecture on LAN architecture. And after the lecture, we will be able to learn the following objectives. Describe the history of LANs, LANs. Explain the concept of LAN protocols. Define Ethernet and token ring. Understand the fiber distributed data interface. Local Area Network, LAN, LAN, is a group of computers and associated devices that share a common communications line or wireless link. The LAN refers to a group of computers interconnected into a network so that they are able to communicate, exchange information, and share resources. Example, printers, application programs, databases, etc. The purpose of physical LAN attachment is to provide an interface that allows the transmission medium, cable, and the LAN station's access protocol to communicate. It provides mechanical, electrical, functional, and procedural specifications for implementing a LAN. Let's now take a look at the history of LANs. As the name suggests, a LAN is local, meaning that it is a proprietary system limited to a finite number of users. It generally serves an area of less than 1 mile. A LAN permits workers, isolated in separate offices, to operate off the same system, as if they were all sitting around a single computer. LANs allow for the transmission of data between workers. In turn, they enable this shared data to be directed to a common printer, serving a larger group of users. This eliminated the need for each worker to have a printer and ensured that the one printer provided was not underutilized. Physical components of LANs. The physical properties of a LAN include network access units, or interfaces, that connect the personal computer to the network. These units are actually interface cards installed on the computer motherboards. Their job is to provide a connection, monitor availability of access to the LAN, set or buffer the data transmission speed, ensure against transmission errors and collisions, and assemble data from the LAN into usable form for the computer. A more recent development in LAN routing is optical fiber cable. This type of wiring uses thin strands of glass to transmit pulses of light between terminals. It provides tremendous bandwidth, allowing very high transmission speeds, and because it is optical rather than electronic, it is impervious to electromagnetic interface. LAN topologies. LANs are designed in several different topologies or physical patterns, connecting terminals. These shapes can range from straight lines to a ring. Each terminal on the LAN contends with other terminals for access to the system. The branching tree topology is an extension of the bus, providing a link between two or more buses. The star network also works like a bus in terms of connection and broadcast. Transmission methods used by LANs. The transmission methods used on LANs are either baseband or broadband. The baseband medium uses a high-speed digital signal consisting of square wave DC voltage. The broadband medium tunes signals to special frequencies, much like cable television. The file server. The administrative software of the LAN resides in a dedicated file server, in a smaller, less busy LAN, or in a personal computer that acts as a file server. In addition to performing as a kind of traffic controller, the file server holds files for shared use in its hard drives, administers applications such as the operating system, and allocates functions. Let's now have a look at transmission methods and media. Transmission media is a pathway that carries the information from sender to receiver. One uses different types of cables or waves to transmit data. Data is transmitted normally through electrical or electromagnetic signals. Types of transmission media. Transmission media is broadly classified into two groups: wired or guided media or bound transmission media. Bound transmission media are the cables that are tangible or have physical existence and are limited by the physical geography. Popular bound transmission media in use are twisted pair cable, coaxial cable, and fiber optical cable. Wireless or unguided media or unbound transmission media. Unbound transmission media are the ways of transmitting data without using any cables. These media are not bounded by physical geography. This type of transmission is called wireless communication. Twisted pair. A twisted pair line, as the name implies, consists of a pair of wires twisted together. Twisted pair lines are suitable for bit rates up to 950 Mbps over short distances less than 100 M and lower bit rates over longer distances. Coaxial cables. Coaxial cables are a type of cable that is used by cable TV and that is common for data communications. Data is transmitted through the center wire, while the outer braided layer serves as a line to ground. Both of these conductors are parallel and share the same axis. This is why the wire is called coaxial. Just like all electrical components, coaxial cables have characteristic impedance. Fiber optic cable. Fiber optic cable consists of a light transmitting core surrounded by a reflective cladding layer. Information is transmitted by focusing a light source into the core and then switching it on and off. Fiber optic cable is not susceptible to loss of signal strength over distance, like copper cable. Fiber optic cable can be either multi-mode fiber or single-mode fiber. Microwaves. Microwaves travels at a higher frequency than radio waves and provide throughput as a wireless network media. Microwave transmission requires the sender to be inside of the receiver. Here are some types of microwaves. Terrestrial microwaves. Terrestrial microwaves are used to transmit wireless signals across a few miles. Terrestrial system requires that direct parabolic antennas can be pointed to each other. These systems operate in a low gigahertz range. Satellite microwaves. Satellite microwave transmission is used to transmit signals throughout the world. Satellite dishes are used to send the signals to the satellite, where it is again sent back down to the receiver satellite. Infrared. Infrared frequencies are just below visible light. These high frequencies allow high-speed data transmission. Infrared transmission can be affected by objects obstructing sender or receiver. These transmissions fall into two categories: point-to-point. Point-to-point infrared transmission signal directly between two systems. Many laptop systems use point-to-point transmission. These systems require direct alignment between many devices. Broadcast. These infrared transmissions use sprayed signal, one broadcast in all directions instead of direct beam. This helps to reduce the problems of proper alignment and abstraction. It also allows multiple receiver of signal. Let's now have a look at the LAN protocols. LAN media access methods. Media contention occurs when two or more network devices have data to send at the same time. Because multiple devices cannot talk on the network simultaneously, some types of methods must be used to allow one device access to the network media at a time. This is done in two main ways. Carrier Sense Multiple Access Collision detects CSMA, CD, and token passing. In networks using CSMA, CD technology, such as Ethernet, network devices contend for the network media. In token, passing networks such as token ring and FDDI, a special network frame called a token, is passed around the network from device to device. LAN data transmissions fall into three classifications: unicast, multicast, and broadcast. Each type of transmission, a single packet is sent to one or more nodes. In a unicast transmission, a single packet is sent from the source to a destination on a network. A multicast transmission consists of a single data packet that is copied and sent to a specific subset of nodes on the network. A broadcast transmission consists of a single data packet that is copied and sent to all nodes on the network. In these types of transmissions, the source node addresses the packet by using the broadcast address. LAN topologies. LAN topologies define the manner in which network devices are organized. Four common LAN topologies exist: bus, ring, star, and tree.
First network topology is the bus topology. Bus topology is the simplest of network topologies. In this type of topology, all the nodes, that is computers, are connected to the single cable called the bus by the help of interface connectors. This central cable is the backbone of the network and is known as bus, thus the name. Every workstation communicates with the other device through this bus, as you can see in this picture. In this picture we can see that all the computers, that is nodes, are connected to a single line, that is the bus of this network. Suppose this bus topology as a school bus route. Now the working in a bus topology happens as a signal from the source is broadcasted and it travels to all workstations connected to bus cable. Although the message is broadcasted, but only the intended recipient whose MAC address or IP address matches accepts it. If the MAC address doesn't match it, it doesn't accept it. Bus. Now this school bus is coming from a source, the school, and it has children in it, that is the signals, and it is sent to their bus stops, that is their workstations, via the bus cable, that is the school bus route. All the children are sent into a single bus. When the bus stop matches with the child gets down, and thus the processing is complete. Next network topology is the star topology. In star topology, all the components of the network are connected to the central device called hub, which may be hub or a router or a switch. Unlike bus topology, where nodes were connected to a central cable, here all the workstations are connected to a central device with a point-to-point connection. So it can be said that every computer is indirectly connected to every other node by the help of a hub. Suppose this star topology as a solar system. In a solar system, what happens is the sun rays from the sun reach all the 8 planets, and same happens in a star topology. The data on the star topology passes through the central device before reaching the intended destination. Hub acts as a junction to connect different nodes present in star network, and at the same time it manages and controls whole of the network. Depending on the which device is used. Hub can act as a repeater or signal booster. Central device can also communicate with other hubs of different network. UTP, unshielded twisted pair Ethernet cable, is used to connect workstations on central node. Advantages include that a new node can be added easily, such that in solar system also a new planet can be removed or added easily. That recently happened with Pluto being removed. Failure of one link doesn't affect the whole performance of the sun. Next network topology is the ring topology. Ring topology, all the nodes are connected to each other in such a way that they make a closed loop. Each workstation is connected to two other components on either side, and it communicates with these two adjacent neighbors. Data always travels around the network in one direction. Ring topology can also be considered as a group of children sitting in a circle and playing Chinese whisper. In this game, people send whisper messages on a one-to-one basis that stands for a point-to-point communication like in ring topology. Also, with each delivery, the message gets distorted. Message always flows in one direction. We can see in this picture how these children are sitting in a group of a circle, and thus they are transmitting messages, thus depicting the ring topology.
The next type of topology is the mesh topology. Mesh topology is a type of networking where each node must not only capture and disseminate its own data but also serve as a relay for other nodes. That is, it must collaborate to propagate the data in the network. A mesh network can be designed using a flooding technique or a routing technique. When using a routing technique, the message propagates along a path by hopping from node to node until the destination is reached. To ensure all its path availability, a routing network must allow for continuous connection and reconfiguration around broken or blocked paths using self-healing algorithms. A mesh network whose nodes are all connected to each other is a fully connected network. Mesh networks can be seen as one type of ad hoc network. Mobile and ad hoc networks and mesh networks are therefore closely related.
LAN devices. Devices commonly used in LANs include repeaters, hubs, LAN extenders, bridges, LAN switches, and routers. A repeater is a physical layer device used to interconnect the media segments of an extended network. A repeater essentially enables a series of cable segments to be treated as a single cable. A hub is a physical layer device that connects multiple user stations, each via a dedicated cable. Electrical interconnections are established inside the hub. Hubs are used to create a physical star network while maintaining the logical bus or ring configuration of the LAN. A LAN extender is a remote access multi-layer switch that connects to a host router. LAN extenders forward traffic from all the standard network layer protocols such as IP, IPX, and AppleTalk, and filter traffic based on the MAC address or network layer protocol type. Bridges analyze incoming frames, make forwarding decisions based on information contained in the frames, and forward the frames toward the destination. In some cases, such as source route bridging, the entire path to the destination is contained in each frame. Switches are data link layer devices that, like bridges, enable multiple physical LAN segments to be interconnected into a single larger network. Similar to bridges, switches forward and flood traffic based on MAC addresses. Let's now get to know about Ethernet and Token Ring. Ethernet is the most widely installed local area network, LAN, technology. An Ethernet LAN typically uses coaxial cable or special grades of twisted pair wires. Ethernet is also used in wireless LANs. The most commonly installed Ethernet systems are called 10 base T and provide transmission speeds up to 10 Mbps. Fast Ethernet or 100 base T provides transmission speeds up to 100 megabits per second and is typically used for LAN backbone systems, supporting workstations with 10 base T cards. Gigabit Ethernet provides an even higher level of backbone support at 1000 megabits per second. Ethernet frames. The DIX or DIX V2.0 frame, frequently referred to as the Ethernet 2 frame, consists of an 8-byte preamble, 6-byte source and destination addresses, a 2-byte type field used to identify higher layer protocols, a variable data byte field, followed by a 4-byte frame check sequence, FCS field. Destination address. In the DIX standard, the first bit of the 48-bit destination address indicates if the address is a multicast address or a physical address. The IEEE standard further defines the second bit of the 48-bit destination to indicate if the address is locally administered or globally administered. Source address. The 48-bit source address is appended to the transmission as an aid to the higher layer protocols. To avoid duplicate node IDs for global addresses, the Ethernet adapter manufacturer obtains an organizationally unique identifier, OUI, from the IEEE for an administration fee. The OUI is 24 bits long and is used as the most significant portion of the 48-bit address. Ethernet physical layers 10 base F. The 10 base F standard is actually a series of fiber optic standards. The 10 base FL standard requires a duplex 62.5/125 mu M fiber optic cable for each link. Transmission distances of up to 2 kilometers are possible, as well as full duplex operation. Let's now take a look at token ring. A token ring network is a local area network, LAN, in which all computers are connected in a ring or star topology, and a bit or token passing scheme is used in order to prevent the collision of data between two computers that want to send messages at the same time. The IBM token ring protocol led to a standard version, specified as IEEE 802.5. Both protocols are used and are very similar. The IEEE 802.5 token ring technology provides for data transfer rates of either 4 or 16 megabits per second. Token ring comes in standard 4 and 16 Mbps and high-speed token ring at 100 Mbps, IEEE 802.5T, and 1 Gbps, IEEE 802.5V. Many mainframes, and until recently, all IBM mainframes, used a front-end processor, FEP, with either a line interface coupler, LIC, at 56 kbps, or a token ring interface coupler, TIC, at 16 Mbps. Let's now have a look at Token Bus. Token Bus was a 4 Mbps local area networking technology created by IBM to connect their terminals to IBM mainframes. Token Bus utilized a copper coaxial cable to connect multiple end stations, terminals, workstations, shared printers, etc., to the mainframe. The coaxial cable served as a common communication bus, and a token was created by the Token Bus protocol to manage or arbitrate access to the bus. The token bus was standardized by IEEE Standard 802.4. It is mainly used for industrial applications. Token bus was used by GM, General Motors, for their manufacturing automation protocol, MAP, standardization efforts. Let us now understand the Fiber Distributed Data Interface, FDDI. Fiber Distributed Data Interface, FDDI, is a local area network protocol standardized by ANSI and the ITU-T, ITU-T X.3. It supports data rates of 100 Mbps and provides a high-speed alternative to Ethernet and token ring. When FDDI was designed, speeds of 100 Mbps required fiber optic cable. Access method, token passing. In FDDI, access is limited by time. A station may send as many frames as it can within its allotted access period, with the proviso that real-time data be sent first. To implement this access mechanism, FDDI differentiates between two types of data frames: synchronous and asynchronous. Synchronous here refers to information that is real-time, and asynchronous refers to information that is not. These frames are usually called S frames and A frames. Time registers. FDDI defines 3 time registers to control circulation of the token and distribute link access opportunities among the nodes equitably. Values are set when the ring is initialized and do not vary in operation. The registers are called synchronous allocation, SA, target token rotation time, TTRT, and absolute maximum time, AMT. Timers. Timers can be set and reset, and their values decremented or incremented at a rate set by the system clock. The 2 timers used by FDDI are called the Token Rotation Timer, TRT, and Token Holding Timer, THT. Time taken by the token to complete a cycle. Electrical specification, signaling, physical layer. FDDI uses a special encoding mechanism called 4 bits, 5 bits, 4B/SB. In this system, each 4-bit segment of data is replaced by a 5-bit code before being encoded in NRZ. The FDDI standard divides transmission functions into 4 protocols. Physical Medium Dependent, PMD. Physical, PHY. Media Access Control, MAC. And Logical Link Control, LLC. These protocols correspond to the physical and data link layers of the OSI model. Media Access Control. The FDDI MAC layer is almost identical to that defined for Token Ring. Although the functions are similar, the FDDI MAC frame itself is different enough to warrant an independent discussion of each field. Each frame is preceded by 16 idle symbols, 1111, for a total of 64 bits, to initialize clock synchronization with the receiver. Implementation. Physical Medium Dependent, PMD layer. The Physical Medium Dependent, PMD layer defines the required connection and electronic components. Specifications for this layer depend on whether the transmission medium used is fiber optic or copper cable. Let's now take a look at wireless LANs. A WLAN provides wireless network communication over short distances using radio or infrared signals instead of traditional network cabling. A WLAN typically extends an existing wired local area network. The WLANs are built by attaching a device called the access point, AP, to the edge of the wired network. Wireless technology has helped to simplify networking by enabling multiple computer users to simultaneously share resources in a home or business without additional or intrusive wiring. These resources might include a broadband internet connection, network printers, data files, and even streaming audio and video. Wireless LANs in the office. Wireless networking allows for impromptu meetings in cafeterias, hallways, courtyards, or wherever inspiration strikes, while providing real-time LAN connectivity for business applications such as sending email, working on spreadsheets, on shared drives, and conducting market research. Wireless LANs in the home. Home users can create a wireless network out of an existing wired network and wirelessly extend the reach of the internet throughout the home on multiple computers, making it more convenient for everyone to get online. Now, in the end, let us summarize what we have learned in this lecture. Personal computers transformed LANs, LANs, from mere shaped processors to fully integrated communication devices. The physical properties of a LAN include network access units, or interfaces, that connect the personal computer to the network. Transmission media is a pathway that carries the information from sender to receiver. Coaxial cables are a type of cable that is used by cable TV and that is common for data communications. A LAN is a high-speed data network that covers a relatively small geographic area.